Hey there, tech enthusiasts. Welcome back to Z Tech Advisor. In series of videos on CASP Plus 4 course, today, we're diving into the exciting world of gateways. Gateways. Let's delve into the diverse array of gateways utilized within enterprise networks, each fulfilling specific roles critical for network operation and security. We'll explore NAT gateways, Internet gateways, API gateways, and XML gateways, understanding their distinct functionalities and optimal applications. Beginning with NAT gateways, also known as Network Address Translation Gateways, they serve as conduits enabling endpoints lacking public IP addresses to access the Internet securely, shielding them from inbound Internet connections. For instance, envision a scenario where 10 workstations reside on a subnet with private IP addresses. Without a NAT gateway, these machines would be unable to access the Internet for updates or online browsing due to the limitations of private IP addresses. In such cases, a NAT gateway steps in, employing network address translation or port address translation to facilitate seamless communication between the workstations and the public Internet. Notably, NAT gateways play a pivotal role in cloud-based networks, facilitating connectivity for private cloud resources or outbound requests. It's essential to remember that connection requests via NAT gateways must originate from outbound traffic directed towards the Internet. On the other end of the spectrum, we encounter Internet gateways, offering a reverse function compared to NAT gateways. These gateways enable inbound connections initiated from the Internet to be relayed or proxied to internal resources. For instance, if you have servers stationed in a DMZ with private IP addresses, an Internet gateway equipped with public IPs can intercept inbound connections and route them to the appropriate servers based on their private IPs. This mechanism mirrors the functionality of a reverse proxy, enhancing network security by preventing direct Internet access to internal servers and allowing for inbound request filtration and load balancing across multiple servers. The role of Internet gateways, which facilitate inbound connections initiated from the Internet and then relay or proxy them to our internal resources. Picture this. You have 10 servers stationed in your DMZ, each assigned private IP addresses. Now, to enable external access to these servers, you can set up an Internet gateway equipped with public IPs. This gateway listens for inbound connections and intelligently routes them to the appropriate servers based on their private IPs. Drawing parallels to our discussion on reverse proxies, a reverse proxy serves a similar function to an Internet gateway. Imagine you're developing a new web application on one of your internal servers, designed to deliver practice exams to your students. Given that your internal network relies on private IP addresses, attempting to access the practice exam server directly from the Internet would be futile. To overcome this, you configure a public IP as an Internet gateway or reverse proxy. This gateway intercepts incoming requests from users, relaying them to the internal private IP of the practice exam server on their behalf. This setup not only safeguards your internal server from direct Internet access, but also enhances network security while providing opportunities for inbound request filtration and load balancing across multiple servers. Now, let's transition to the third type of gateway, the Application Programming Interface, API, gateway. Functioning as a reverse proxy, the API gateway intercepts all incoming API calls within the network. Whether it's requests for data or functionality, the API gateway efficiently aggregates the necessary services to fulfill these calls, ensuring seamless communication between users and the network's resources. Let's explore further the role of the API gateway in managing incoming requests within the network. Upon receiving API calls, the API gateway undertakes the task of aggregating the necessary services to fulfill these requests, ensuring an appropriate response is delivered to the requester. Consider the scenario of streaming a movie on Netflix. When you initiate this action, you're essentially connecting to the Netflix API gateway. This gateway then springs into action, analyzing various factors such as your location and the device you're using, be it a laptop, smartphone, tablet, or TV to determine the optimal services and servers needed to fulfill your request. Every user requesting the same movie undergoes this process, with the API gateway tailoring its response based on individual parameters. The API gateway's role as a reverse proxy offers an added layer of security by preventing direct connections to the API itself. Furthermore, it grants administrators the ability to implement filtering and access controls to these requests before they're forwarded to the API for fulfillment. Now, let's shift our focus to the fourth type of gateway, the Extensible Markup Language (XML) gateway. While similar to an API gateway, the XML gateway specializes in handling data requests formatted in XML. Unlike its more generic counterpart, the API gateway, which supports various formats like JSON and XML, the XML gateway is tailored specifically for XML data. In essence, it functions as an XML firewall, offering filtering and access controls focused solely on XML format inbound data to the API, thereby enhancing network security measures. And that's it for today's tutorial, folks. Hopefully, you found this guide helpful. Don't forget to like this video if you enjoyed it and subscribe to our channel for more tech tips and tricks. Thanks for watching, and until next time.